Let's begin. We have limit as x approaches 1 of x to the negative 1 minus 1 over x minus 1. If I plug in 1 for x, I get 0 over 0. So now I'm going to rewrite the x to negative 1 as 1 over x, and I'm going to leave everything else the same. Now in the top, I want to get a common denominator of x. So I'm going to multiply the top and the bottom here by x. So I have limit as x approaches 1, 1 over x minus x over x, all over x minus 1. Limit x approaches 1. Now I can combine these two fractions under common denominator of 1, and I have 1 minus x at the top and x minus 1 at the bottom. So here I have a fraction 1 minus x over x, and I'm dividing by x minus 1, which is really the same thing as multiplying by 1 over x minus 1. So this x minus 1 is going to come over here. And here's the work for it. So I'm dividing by x minus 1. So that means I'm multiplying by the reciprocal. So let's write that. Limit as x approaches 1. I have 1 minus x over x times x minus 1. I'm going to factor out a negative 1 from the top. So I have x minus 1 left. And then the bottom is going to be the same. And the reason I factor out a negative 1 is because now x minus 1 is going to cancel with the bottom, x minus 1. And if I evaluate this limit at x equals 1, so I plug in x equals 1, I get negative 1 as my limit. Let's look at another fraction at the numerator, limit. So we have limit as x approaches 0, 1 over x minus 1 plus 1 over x plus 1 over x. If I plug in x equals 0, at the top I have negative 1 plus 1 over 0. Okay, so that's 0 over 0. In this case, I'm going to get a common denominator, and I'm going to combine the two fractions. So I'm going to multiply this fraction by x plus 1, and I'll multiply this fraction by x minus 1, x minus 1. So we have limit as x approaches 0, x plus 1 over x plus 1 times x minus 1 plus x minus 1 over x plus 1 times x minus 1, all over x. They both have the same denominator, so I could just add these. I have x plus x, which will be 2x, and then 1 and negative 1, well, those just cancel. So I have limit as x approaches 0 of 2x over x plus 1 times x minus 1 all over x. This x on the bottom here is going to come over here, and that's going to end up canceling with this x. And now if I plug in x equals 0, I get 2 at the top and negative 1 at the bottom, so my final limit is negative 2. Let's try another one. I have limit as u approaches 1 of u to the 4th minus 1 over u cubed minus 1. If I plug in 1, I get 0 over 0. So I'm going to have to factor the top and the bottom. So the top is a difference of two squares, so I can say it's u squared minus 1, u squared plus 1. And in the bottom, it's going to factor into u minus 1 and u squared plus u plus 1. And the reason I know that is because in order to get u cubed, you have u times u times u, and then 1 is 1 times 1 times 1. So here we have to use what's called the SOAP method. So I'm going to have a u and a 1, and then in here I'm going to have u squared, I'm going to have u, and then 1. SOAP stands for same, opposite, and always positive. Here I have u cubed minus 1, so the same sign will be a minus for the first one. The next is opposite, so the opposite of minus is plus. And the last one is always positive, so that's going to be a plus. So that's how I get that. I'm going to go a step further now, and I'm going to factor out the u squared minus 1. So it's going to be u minus 1 times u plus 1, and that's u squared plus 1 over u minus 1 times u squared plus u plus 1. I have a u minus 1 factor in the top and the bottom, which is going to cancel. And here nothing else cancels. So let's try plugging in u equals 1. I get 1 plus 1 is 2. 1 squared plus 1 is 2. And the bottom I get 1 plus 1 plus 1. So my answer is 4/3. So this was a good test of our algebra skills. Similarly, if we try limit as v approaches 2 of v cubed minus 8 over v to the 4th minus 16. I have a cube at the top and a 4th degree on the bottom, so this is basically what we did in the last problem. So v cubed is v times v times v. 8 is 2 times 2 times 2. I'm going to have two parentheses, or two sets of parentheses. One will be v, the other one is 2. And now I could just group these. I have v times v is v squared. V times 2 is 2v. 2 times 2, that's 4. If I use SOAP, S stands for same. Here I have a minus, so it's going to be same. Then O is opposite, that's going to be plus. Last one is always positive, so that's a plus. And the bottom I have v to the 4th minus 16. So if we do this on the side, we know this is a difference of two squares. So it'll be v squared minus 4 times v squared plus 4. And v squared minus 4 is v minus 2 times v plus 2 times v squared plus 4. So let's take all of this and plug it back in here. So we have limit as v approaches 2. The top is v minus 2 times v squared plus 2v plus 4. The bottom now turns into v minus 2 times v plus 2 times v squared plus 4. The v minus 2's cancel. And now I can plug in v equals 2. So we have 2 squared is 4. 2 times 2 is 4. And we also have another 4 here. On the bottom we have 2 plus 2, that's 4, times v squared is 4 plus 4. So 4 plus 4 plus 4 is 12. Let's say 4 plus 4 is 8, times 4 is 32. Divide top and bottom by 4. We get 3/8 as our limit. Okay, let's try one more. I have limit as x approaches 9 of square root x minus 3 over x minus 9. If I were to plug in x equals 9, I'm going to get 0 over 0. So the key to doing this problem is to multiply the top and the bottom by the square root x plus 3. And that's going to be the conjugate. So square root of x plus 3, square root of x plus 3. The top is just a difference of two squares, so you have a minus b times a plus b, which is just a squared minus b squared. So limit as x approaches 9. Square root of x times square root of x is x. Negative 3 times 3 is negative 9 over x minus 9. And we're going to leave this factored. We're not going to distribute, times square root of x plus 3. X minus 9s will cancel, and we have 1 over square root x plus 3. We plug in x equals 9 to get 1 over 6 as my final answer.